This ties really good with this chapter where identifying conductor is a big deal. As I said, I'm holding in my hand the three-phase circuits with a grounded conductor and a grounded conductor, three ungrounded conductors, right? I'm also holding in my hand another grounded conductor, and another three-phase. The difference, anybody can tell me what the difference between these two color coding systems?
You're using yellow instead of blue.
Okay,
For a hot.
for a hot. So this is not code, but the code says, guys, and we get into this one when we go in a commercial business. If you have, so you have your 208/120 volt, and you have your 480/277. These are three-phase systems. These are your three-phase systems that you're going to be having. So we have the colors that we're going to use is black, red, blue. Black, red, blue. You can see for this one, black, red, blue, and we have white, white, and also green or bare conductor. This system that you're looking at is commonly used with 208/123 phase system. 208/123 phase system. 208/123 phase system. The second one, we have brown, and we have orange and yellow, plus gray, plus of course green. I'm going to say green with M. This is the other system that you guys are looking at. This is commonly used with 480/277. Now, Phil, take this. If you are to install a system in a building like Dunwoody, branch circuits and feeders. If you have a building like our building here at Dunwoody, and you're using 2-voltage system, which we're using 480 coming from Excel, feeding our machines, all our machines with 480/277, and our equipment, other equipment, lights and receptacles, conveyor receptacles are fed with 208. Starting in 2008, as a matter of fact, if you have 2-voltage systems in your building, you have to color code your conductor as follows. They have your hots. If you guys look at my hots in the 480 system are completely different color than my hots in the 208 system. My neutral in the 208 system is completely different color than my neutral in the 480 system. The grounding conductor is the same. As of 2008, if you have 2-voltage systems in your building, only if you have 2 voltage, 99% of the time you have 480/277 guys to feed your mechanical equipment, large loads, 208/120 to feed your lights and conveyor receptacle. And most of the time, just conveyor receptacles. If you're in this situation, Chris, then the color code that you're looking at is a must. Now, if you only have 1-voltage system, then you can use this color code or this color code, the top or the bottom. The industry standard, not code, industry standard, they standardize, guys, on these colors, which is the top and the black. We have a black, red, blue, white, and green for the upper system, brown, orange, yellow, and gray, and ground, of course, for the lower system. Any question, guys, about these two systems? Any question about these two systems? Just to give you, and I show you guys later on, this is really nice about the identifying of conductors. Let me tell you, do you see that circuit here in my hands? Right here in my hands, I'm holding 100, close to 120 lighting fixture, feel like the one above your head. From these 5 conductors, 3-phase, neutral, and a ground, I can feed 120 fixtures like the one right above your head. 120 fixtures from this system. 3-phase system, 480/277. So I can, if these fixtures are 480/277, I'm burning them at 277, line to ground. I can feed 120 fixtures like these above your head from these conductors you're looking at. A lot of power. Huh? Number 12. Number 12. These are number 12. These are number 12. Number 12. When you go commercial, you don't use number 14. Just to give you an idea. Take this. Now I'm using a 28120. If the same wires, it's the same insulation except 28120, I can feed half of this if I burn them at 120. So if burn them at 28120. So instead of 120, half of that, almost 60 fixtures, you can feed like the one above your head. 60 of these, you can feed them from a three-phase 28120 system like this. Does that give you guys the gravity of what we're doing with these systems? That's a three-phase circuit. Three-phase circuits. The only difference between them is this is 480 277. This is 28120. Since we're residential, guys, most of the time you're going to be using these systems except minus the blue. Since we're doing residential, you're going to use black and red, and you're going to exclude the blue because we have two hots. We don't have three hots, right? Black, blue. You're going to have the white and the green. So as I pass this one just for residential, imagine the blue doesn't exist here, and that's your system for residential. 240, 120, single phase. Does that make sense, guys? Does that give you the gravity of what you're doing? So you can feed a lot of powers. Color, I have a color code circuit. I use this in the commercial. I'm going to pass these. The reason why I pass this is because it talks about conductor identification. This is how your conductor should be identified. So I'm going to pass these, guys. Let you, from Chris, my friend, let you look at the, I know I've seen a lot of wires, but I don't know if you've seen them bundled like this together. Bundled together like this. Okay, and now if you were sleeping and you want to wake up right now, up to conductor number 6. Up to conductor number 6. Can I borrow your stuff here? Up to conductor number 6. Up to conductor number 6, the conductors themselves have to be color coded, meaning the insulation has to be color coded. Up to conductor number 6. This is very important, guys, because up to conductor size number 6, the conductor has to be color coded, exactly like you're looking at. Larger than conductor number 6, number 4 or larger, number 4 larger, I have the options then. I can have them color coded like you're looking at. This is a 4-aught, I believe. You're looking at a 4-aught feeder. You can have them color coded, or you can have them all black. Did you guys hear the difference? You can have all of them are black, but you have to re-identify the others by a tape or a tag, or usually a tape. So with a tape around them, so I can have all these 4 conductors because they're 4-aught, larger than number 4. I have 2 options. I can color code them like this, which the industry is moving towards having color code. Beautiful. You can look at the cable, you can tell exactly which these are the 3-phase, right? You can see them, right? And you can see the neutral. And you can tell from an industry standard, this is a 28123-phase system, just by looking at them right now. Now, that's not code. That's code. Up to this one, it means the codes that exceed the codes. Or I can have 4 of this black, or 4 of this blue, or 4 of this red, not the white though. 4 of any of these black, red, or blue. I can have 4 of them, and have a tape around them and tape them with these colors that you're looking at, as well as the neutral. So I can use a black and put a white tape around it, and that conductor becomes wherever I can see it. In every termination where you see it, you put a white tape around it, and that conductor, the black, becomes a grounded conductor. Or I can put a green around the black conductor, and that conductor becomes a grounded conductor. Only if the conductors are which size or larger? Number 4 or larger. So that's Zach. When we do field trips, the students will walk in and say, "Chad, did you see what I saw?" I say, "What did you see?" "I saw all these grounding, bonding conductor, and they're all black." "Yeah, no problem. They're black. No problem with them being black, as long as they identified with the ground, with the tape, green tape, or if they're grounding conductor, guys, sometimes they cut like 2 inches of insulation, remove 2 inches only for the grounding conductor. They take, if this would be a grounding conductor, I come and take close to 2 inches of insulation, expose it, so, and tie it to something here. When I look at it exposed, if it's exposed, it's there. If it's bare, most likely it's a grounding conductor. Did you guys get the message?
Yeah.
Number 4 or less must be color coded. Larger than number 4, it could be color coded, or it could be taped in the field to indicate these colors, though. Okay? So listen to
the identification.
You have to re-identify it. Only if it's larger than number 4. And number 4 larger. Any question guys about this? Any question about this? So that's where I thought to pass. And please give me my cover because I like them. These are, the industry is moving more and more, guys. You're looking at 4-aught. You're looking at 4-aught. This is a 225 amp panel. You're looking at it, either 28120 or 48277. Your choice, voltage-wise. Now, is it wrong if I use this one with 48277 or 28120? No, it's not wrong. If you have two systems in your building, you have to use these two color codes or equivalent. So you're looking at 4-aught with a ground. You're looking at 4-aught here with a neutral. I don't have a gray conductor that goes with these. Usually the grounded conductor here, I have it with a smaller conductor, guys. So I'm going to pass these and a 4-aught, give you an idea how a 4-aught is. Any question, guys, about color coding of conductors? This is the single most important thing. Single most important thing. Since we are, I brought you guys, how many of you have installed the new tamper resistor receptacle? How many of you have installed the newly tamper resistor receptacle introduced in 2008?
How do we know if they tamper resistant?
That's exactly what you're going to see here. Tamper resistance, if you guys look at the eyes of this receptacle right here in front of me, there's that little plastic cover that covers the grounded conductor size and the grounded conductor size. And in order to engage this receptacle, if I have a plug, in order to engage this receptacle, you have to push both of them. In order to engage the receptacle, you have to push both the grounded conductor slot, the bigger one, and the ungrounded conductor, the hot slot. One more time. And I switch gear here for devices. Devices, you're looking at a tamper resistant receptacle. It looks like every other receptacle you have seen in your house or around. 2008, these are required in a lot of places. In 2011, they expand the use of them. Now, my friend, these are required right now in every receptacle that you install in dwellings. Every receptacle, from GFCI into non-GFCI, all of them have to be tamper resistant.
Why?
This is why? Because if a kid is to push a paper clip like this, if you were to push, well, this is too big. If you were to push a paper clip right into one slot, it wouldn't engage. It would not allow you to go inside. You want to try it? I'm sure one of you can defeat it. Yeah, if you guys, I can push that. I can give you that little thing and try. If you push it in the ground or in the neutral area or in the hot, you can't push it enough. But you can push two of them at the same time. I hate to be a vendor. I'm not a vendor, but there you go. Two paper clips. Now, if you do that one, if you put two paper clips and you push them at the same time, look, if I push two paper clips at the same time, they go down. Well, if a kid is to push two paper clips right into the hot and the neutral, a father of 3 children each, I hate to say it, but it's called natural selection. But if you are to push one of them at a time, you can't. Okay, I don't know how to get them out now. They get stuck. Well, that's interesting. They get stuck too. So.
Yeah, I
Did you
installed
get
a couple of GFCIs like that.
They get stuck. They don't.
They're tough to get in, and then
Yeah.
they have to pull off.
Okay, I have two paper clips, guys. So I have two types. One is decorative type, beautiful, supposed to be, and one is the normal one. Both of them tamper resistance. These are required in every residential dwelling unit. So I'm going to pass these. I have two paper clips if anyone will defeat them, and it should be both of them will go, but one at a time will not. So here's your receptacles and your two paper clips if you guys want to practice defeating the system. Just for the people who like Chris and myself who are kind of don't have to question a lot of things, right, Chris? And me, not you, but Chris and Nick and I. When these came to be, guys, the people were mad at the code because the ones that you're looking at, these tamper resistance, they are $1.30 now. $1.30 versus if you buy one of these without tamper resistant, they're 14 cents, 30, 35, 40 cents. So they become 2 to 3 times more expensive tamper resistor receptacle than non-tamper resistor receptacle. So people start complaining, right? So I happened to be in England around that time, and I bought myself one of these British receptacles. These are 230. They're 250. They're rated for 250, but they run them, I believe, at 240. They're 12 amps, if I remember right. I should 13 amps. They're 13 amps. This receptacle come as a standard, guys. A British. This is equivalent to the one that you're looking at, with a switch. So before you unplug things, you turn it off with a switch, standard. And of course, hot, neutral, and ground, like we do. You have your hot, your neutral, and a ground. Typical to us. Different configuration, but typical. This will cost you in American dollars $7. Just to put things in perspective. It cost me $7. I'm sure you can have deals and all this stuff, but if you're to buy two one at a time, ours here will cost you $1.30. This will cost you $7. Just to put things in perspective. So I thought it came to a big deal when we were into, and this is, by the way, tamper resistant. You can look at the tamper resistant standard like ours. They have been tamper resistant for a while. And if you can look at tamper resistant for all of them.
So you hit the switch before you unplug it?
Typically, yeah. Instead of arcing, you hit the switch, and you can unplug it without hitting the switch. But it's if you hit the switch, you de-energize the circuit. When you unplug it, then it doesn't arc. Safety. Any question, guys, about these? I thought to show you these a few things before we go ahead and even start with our lecture. So our lecture, guys, for today is identifying of switch control circuits, grounding, bonding conductor. I hope that quick introduction that I did, guys, about the grounding. When you graduate from here, you should understand fully the colors that we use with the grounded conductor, which is gray or white for the most part, right? Or grounding conductor, which is bare conductor or green. Ungrounded conductor, any other code, any other color. I told you guys the commonly used conductors. The second thing about identifying conductors also, if you have two voltage system in a building, you have to identify by system and by phase. For example, here's phase A. Look at this is. This is phase A here. This is phase A here. Phase A and 208 is black, brown, and 480. So you have to identify them by system as well as by system. Look at them. They're completely different system, and the phases are completely different color. So if I'm looking at a brown conductor, I know this is, hopefully the old installation is different, so you have to pay attention. But the new installation, a brown conductor, industry standard, not code, would be a system 480. Okay, so that's a couple of things, guys. We'll talk about induction heat and why you have to group them like I did in a second here. Okay, grounded conductor, types of toggle switches, lighting circuits, control, switches rating. Okay, type of lighting installation, neutral conductor in a box, and a few other things. Okay. Grounded conductor, guys, we just talked about this. I decided to show you immediately. Grounded conductor, this is the one that you've just identified, your white or your gray, right? You guys have looked at it, your white or gray, or 3 continuous white stripes. Sometimes either complete solid white or solid gray, or 3, you can have any other color, but with a 3 continuous white stripes on it. Any question about identifying the grounded conductor? Everybody knows what the grounded conductor is? The grounded conductor is the conductor that's intentionally tied to Mother Earth. When we go to the moon, then we tie it to Mother Moon. And grounded conductor, that would be the moon conductor. Can we say that? Okay, come and refer to the neutral. This is your neutral. So in residential, as you know, the neutral conductor must be ground. All neutral conductor must be ground conductor. Any question about the grounded conductor? Any question about the grounded conductor, guys? And let me grab my demos here. Oh, we have a lot of stuff here. Yeah. I just need the conductors. I can look at the others. But I want one of these at least. Okay, so grounded conductor, white, gray. I can't emphasize, guys, that. Okay, cable for conductors, grounded conductor, you're white or you're gray. Here's what we're talking about, my friends. Here's my conductor, red. In residential, you're looking at these three and the neutral, right? We said the blue, get the blue out of the way. You're looking at these. Here's a residential circuit. Black, red, white, and green. Or bare, usually bare in a residential circuit. Okay, so if you have not known that, please realize that these two are the ungrounded conductor, the hot, so-called ungrounded conductor. This is the grounded conductor, which is the neutral, and this baby is the ground. Everybody can identify these in any circuit, three-phase or single. This is a single-phase circuit. Why single-phase circuits coming from two hots? Where's the third phase? Ask yourself, to make this a three-phase circuit, let me make it right on the spot a three-phase circuit for you guys. Now what you need to do is just add another transformer here and pull another circuit, and this will be phase A, phase B, phase C. Done. And this baby is a three-phase circuit. Here's my phase, and suppose I want to tie this is just phase to neutral. You come over here and you tie it to the neutral. Done. I made this single phase three-phase circuit by adding a third phase. Well, granted, the transformer, I'm making a symbol here, the transformer will be different, the voltage will be different, but for the most part, that's what two hots are like two phases, they're not two phases, they're like two phases. Add the third phase, and you've got yourself the same system, change into a three-phase system. The voltage will be different, complainer, it's not going to be 24120 anymore, it'll be 28120 or 48277. Any question, guys? When I teach wiring, guys, I always say, to make the system work, all what you need is one hot. To make this system work, guys, I can take this to a lamp and tie it from this end to Mother Earth, and it will go on. All what you need to make the system work is only one hot to tie to the lamp or motor or whatever, and the other side you tie to the ground. So why do we have three conductors instead of having one conductor? Number one is efficient. To make it work efficient, guess what the smarter than Chad decided? To make it work efficient, you know what? We're going to go and tie this side to get rid of the ground. Tie. So now it's going to work efficient, meaning it will give us more lights as it rated. Up to this point, we're working efficient, but we're not working safe. To make it work safe, the smarter than Chad again decided to say, take another grounding conductor and tie it to the frame of this fixture, if any, to the frame of this fixture. So I want you guys to understand, for the system to work, we'll only need in a grounded system, all what you need is hot, Mother Earth return. To work efficient, we have a neutral. To work efficient and safe, what do? An equivalent ground conductor. Can I drill that one in your brain? So, single phase, three phase, you name it. I'm going to tell you when it comes to three phase, here's a three phase system. 1, 2, 3. Phase A, phase B, phase C. Where's the neutral? Gone. We don't need a neutral. Three phase does not need a neutral. So the neutral was just a reference if needed. But I still need, with three phase system, I still need a ground, right? Why? Everybody knows why we have a ground. For the most part, safety. Ground is just safety. But three-phase system, there's no neutral. A lot of equipments in three-phase don't need a neutral. Three wires. Efficient. You're giving, think of them as three pipes of water coming to feed a building. Three pipes of electricity coming to feed a building. Okay, so that's my circuit. All right, color. Here's the color code, guys, for systems. Now, granted, we're talking about residential here. So I want you, if you have two wire, you have to have a black and a white and a bare conductor. Again, we're talking about row mix, and we're talking about, as you guys can see, you're talking about row mix here, and we're talking bare, or it could be here, it could be green. Bare or green. That's two-wire cable. If you have a three-wire cable, and these are cables, you're going to have a black, and you're going to have your red, and you're going to have your white now. Black, red, white, and again, or green. Right? And if you have a four-wire cable, you're going to have your black, you're going to have your white, your red, your blue, and your bare, or green. Or gray. Green or gray. And that's the cable that you guys have seen right here, right? The 4-conductor cable, not commonly used. Very people carry it. If you probably go to Menards, maybe they'll start carrying it right now because of the change in the code. 14.4 or 14.4. Any question, guys, about this? Any question about this? Now, what's the difference between a cable and a conduit? A cable, it's already assembled for you. The smarter than Chad, they grab these conductor and they push them right into a cable and they manufacture it. If it's conduit, you have the loose conductor like this, and you yourself create, basically you create the shield for it, and you stick them right into these conduit or any other equivalent. Does it make sense? Conduit or cable. Any question, guys, about the identification? Any question about identification? Now under certain circumstances, guys, you can re-identify the white to be see how we are re-identifying. I can re-identify. Let me tell you where I can in these cables. Only in these cables. Look at this. I have a cable like this, right? And I have 2 hots and a neutral and ground. But I need to feed a 3-phase load from this. How can I 3-phase, 3 hots, no neutral? How can I feed a 3-phase, no hots, no neutral? By the way, don't do it because it's not a good idea. It's not a good practice, but you can. All what you have to do is here's phase A, black, that's 28, 120. Let's say 28, my black, red, and I make thing blue. Put a blue tab over here, and then you got a 3-phase load that you can feed from this cable. It's a poor man or woman's job if you do this particular cable raw mix to feed 3-phase, because you don't want to use this one in a 3-phase system. Just not good industry standard. The same thing, guys. You see this all the time. Suppose I have 2 cables. I've done it many times. So only a 2-cable conductor like this. Now I have a window air conditioning right in the window, and that runs at 240. 240, no 120, right? You guys have seen window air conditioning. How can I feed it from a number 12 conductor like this with 2 conductors? You re-identify this one. This is my red. Make this black. Tie it to the circuit breaker from one side. Make it black. Tie it to the receptacle from the other side. Re-identify the white as a black to be used as an ungrounded conductor is okay. Did you guys get that message? That's okay. Now, here's my question for you. Can I do the opposite? Can I have a conductor like this? Can I re-identify this black to be used as a white? No, unless this conductor is what size or larger? Number 4 or larger. The re-identifying of other way has to be number 4 or larger to start be okay to re-identify this black as a white. Okay? Any question, guys, about that? This is the most commonly, but a white as a black, if I need it, I can re-identify it, a white as a black at any time. That needed it. You know, in this case, the reason why I re-identify here to feed a 240 load or a switched leg or supply to the switch. Most of the time, supply to the switch. You're going to see how we re-identify to supply to the switch. But with the change in the new code, guys, KISS re-identifying for a switch goodbye, because now every switch have to have what? A neutral conductor. So the re-identification with Ryman when stood in front of you, show you how to re-identify, blah, blah, blah. 90% of the time, you will not be able to do it because you need a neutral. Why doing it if you need a neutral? So before I continue, guys, with needing a neutral, neutrals in 2011 are needed only if you're wiring with cables. If I'm wiring with conduit like this, I do not need a neutral to the switch. Anybody can tell me why? You can pull a neutral at any time. You can pull a neutral at any time. So re-identify. Adding a neutral to a switch is only required if you are wiring with cables. There is exceptions even for the cables. I'm wiring with cable in residential, and the wall is open, completely open, basement. No need for a neutral. I'm wiring, did you hear me? Wiring with cables, but the wall completely is open, right? You see in basements all the time. You do not need a neutral with the switch. You're wiring with cable, and the bottom here, like 2 feet of the bottom or 2 feet of the top are open. right? You see that one sometimes in false ceilings where you can fish things from the top. You don't need a neutral with the switch. The idea, guys, if you can have access to adding conductors or wires, then you don't have to have a neutral. But guarantee you guys that inspectors will be enforcing it as if you're wiring with cables. So 99% of the time, you wire with cable. What do you need? A neutral. To a switch, the switch is only lights. If this switch, guys, this switch is switching garbage disposal, which in your case you have. You have a switch that switches garbage disposal. Do you need a neutral right at the switch box? No. Only if the switch switches what? Lights. Only if the switch switches light. Take this. I have a 2-pole switch right here. 2-pole. 2 hots. Do I need a neutral with a 2-pole? And I'm wiring everything 2 hots. No neutral. Just powering 2 hots. Do I need a switch for it? No. Right? I'm gonna burn this baby at 240. Rated for 240. I brought 240 here. There's no neutral. Out of it. Do I need to bring a neutral to this? No. Any question, guys? Any question about wiring with cables? Re-identifying it? When you connect to devices, guys, as you can see, some devices, you guys have looked at the device that I gave you. You can stab them in the back up to conductor number 14 solid, right? You guys have seen it. Number 14 solid, you stab in the back. Everything has to be the holes in the back, as you can see it. Or you can splice them right here on the terminals of this switch, as you can see. And it has to be tight. This is right here, guys. When you terminate your wires, the single point of failure is right at the device. You can't believe how many devices I took out, and that little thing is loose and it's arcing, and half of this is burned. And that's why we put these in boxes. Because if it arcs and burns and it's inside a box like here, highly unlikely that the arc will jump outside that box and burn the stud next to it or anything else. But if you put it right next to the stud and it keeps arcing over time, it could ignite the stud or something else. So that's why we put them. So if they even arc and fail, they're in a box. The worst that could happen is bam, they short circuit and you have no power. You go there and you fix it. Common receptacle configuration. You guys have looked at the receptacles. Everybody knows that I don't like to. Everybody knows that the most important thing is identifying. This is my ground. If you don't know that by now, this is my neutral, and this baby is what? My hot. Done. If you don't know that by now, please do. Otherwise, you're gonna embarrass Mr. Ryman and myself when you go in the field. And when you wire them, you terminate the hot on the hot side, the neutral on the neutral side, and the ground on the ground side. As you know, if you guys have, I'm sure you wired it. These are tied. These two are tied together. These two are tied together, and these two are tied together, like internally. So you don't have to mess around with it. I don't know if you had the split circuit with Mr. Ryman. If you have a split circuit, you're gonna go, guys, to the hot side right here, and basically break this. So you'll have circuit 1, circuit 2 coming. It's usually in this area, right? You cut it, that little cover thing. Now you can land 2 circuits. This becomes hot 1. This will become hot 2. You're going to be doing this with Chad where I suggest to do it. Garbage disposal and dishwasher. And then by doing it this way, guys, your circuit will be hot 1, hot 2, neutral, and a ground. Anybody can tell me what do we call this circuit? Multi-wire circuit. Everybody knows what the definition of multi-wire circuit. A multi-wire circuit is when you have more than one hot with a neutral. More than one hot. So do I have more than one hot sharing a neutral? Sharing a neutral? Sharing a neutral. I hate to use the term with multi-wire branch circuit. It's like polygamy. I hate to use it, but when more a husband is marrying 3 wives, so you can think of this one, the neutral, as the husband. I hate to say that, and these are wife 1, wife 2. You can have up to wife 3 wives here. After that, you're gone. Anybody's a Muslim here? Muslims can have 4 wives. Did they say that? Okay, so that's kind of how I always remember it, is the neutral as a man, and you can I hate to say it, Ashley, but that's kind of some systems work this way. It doesn't work the other way around though. You can't have multi-huts, I guess. So anyway, multi-wire branch circuit. Any question guys about multi-wire branch circuit? More than 2 huts with a neutral. Okay, question. This is Phil. If next time if you don't take advantage of this, you'll be wasting money. And I know there's harmonics and all this good stuff, but take advantage of a multi-wire branch circuit. If you can feed things with multi-wire branch circuits, great. In residential, here's the disadvantage, guys, of residential. Because almost everything has to be an arc full circuit eruptor right now. If I'm to use this circuit configuration, then these 2 huts, this is say 15 amp, they have to be tied together, right? Multi-wire branch circuit must be tied together. And assuming that we only have 2, we don't have a third hut here. Okay, and this is going to be an arc full circuit interrupter. If you guys remember when we went to the square D presentation, they don't make them yet. I believe Colorhammer makes them, but they're expensive. Now remember, if you want to do this in residential, you're asking for an arc full circuit interrupter 2-pole, and that will run you close to $80. Expensive. But the arc full circuit interrupter is around you $35. Arc full circuit interrupter versus one of these dummies here. One of these will cost you $7 square D. With $35, that's 6 times more. 7 times 6. What is that? 7 times 4. How much? 42. So, any question, guys? Any question about that? So 5 times more. So that's, I thought I don't know how many of you guys, I busted a few of these when I was young just to look at what's inside them. Feel free to bust them. I'll give you one if you would like to. There's a lot of copper connection and so forth, but you get into them. Bush-in terminals in the back are only rated for number 14 conductors. The push-in terminals, so don't put number 12. And these are the conductors you don't want to use with. You don't want to use them with aluminum. I don't know how many people use aluminum or stranded wire or number 12. And they're talking, Phil, they're talking about these little holes in the back. I'm sure you installed them. So, no. Okay. First, toggle switches. Switches, guys, I don't have a switch, but you're looking at them in the wall. Toggle switches, general snap switches that we use. There are 2 of them. One of them is rated for AC/DC. If it's rated for AC/DC, and again, snap switches, they're right in the wall here. They're rated as it says. Either you put AC or DC on them. It's resistive only, inductive load, half of the current. Motors not to exceed the rating, marked with key for the load, tungsten load. So there's a few requirements, guys, for these toggle switches if they're AC/DC. The most common ones probably is going to be the AC/DC rated switches, and we use them a lot for resistive load. Inductive load, you have to cut the current by half because of arcing that goes through them. If you have AC load only, and I'm sure Gary told you about the cold resistance is much higher than the hot resistance. That's Dilmar. Here's an AC cable only. Look at the advantage of an AC. You can't put DC on it. Resistive or inductive any load. Perfect. Look at any load. No cutting. That's the one that we're using there. And not to exceed the rating on tungsten filament lights, meaning that these lights, if it's rated for 2 amps, don't exceed it. And for motors, 80%. So that's where you're basically going to be AC general use snap switches. AC general use snap switches give you look at the advantage of them. No derating whatsoever. You don't derate whatsoever. So here's my switch, and here's my load. I can have, if my load is resistive, or if my load is tungsten filament, or if my load is motor. The only thing you need to derate a little bit if your load is motor, and we'll talk about motors. When can you use a snap switch for motor, guys? Only for fraction horsepower, and you have to limit it to 80% of its size. Any question about switches? The most important thing that happens in switches is we need to land what? A neutral not land and neutral, but bring a neutral to every box that has a switch in it. Okay, re-identification. And I know that Gary likes to do that a lot with you guys. But if you have not gotten it from Gary, when you re-identify, which you're going to be kissing goodbye now because of what? Because you have to have a neutral. Now this picture that you're looking at right now is violating the code 2011. This picture is a violation of code 2011. Can you guys see that?
What happened to all the wiring that has been done before now?
Grandfather then. So when we drop, as in dropping dead, that's how it happens in every code. You do it for the future generations. So, but it will stay for a long time. People have to, and new electricians who are going to come later on, they're going to think every receptacle have a switch, but they will realize soon that not every receptacle has a switch. Has a neutral. Not every switch has a neutral. Yeah, there's a lot of things that grandfather then, guys. At one time they used the orange as a neutral conductor. So there's a lot of mistakes. And if you are confused, go to Europe and see how they switch there. All of a sudden, the blue used to be phase A, and the black used to be the neutral, and now they switched them. Now imagine going into a building that blue, every time you looked at the blue was phase A, now blue is a neutral and black is phase A. Look at the confusion. So there's, every time they switch to a system, there's grandfather there. Okay, now everybody, I'm going to just remind you one little thing, Phil, my friend. Everybody knows how when we re-identify, the one that we re-identify is the one that brings the power to the switch, not the one that takes the power from the switch to the light, right? The idea, Chris, and I'm just going to repeat it one more time because you guys, the idea is you should not land two whites on one light. If you made a mistake, if you grab this wire and put it right here, re-identify it, you have two whites landing on one light, violation, okay? That's the idea of re-identifying. So that's why I re-identify, and re-identifying only with cables. I can't do this with a conduit. Why? Because Chad, if you have a conduit, you can pull any color code wire. If I have a cable, sometimes I'm only limited with certain colors in a cable. Okay? Two things. This is only cable. This is no longer meet the requirement of 2011. When I re-identify, guys, I only re-identify the one bringing power to the switch. Everybody's okay with that? Where to identify now? This is violation of 2011. Let's make it correct. This is a violation of 2011 right now. So to make this correct, what I need to do, my friends, let's correct this. Can you guys correct that one? It's going to go grab a conductor from here and land it into, bring the hot right in here. Okay? And take my white from this side and land my white right here and get rid of this. Now we corrected the mistake. So what would that tell you how many conductor you have to use? This is 14.3. So now kiss goodbye, you're 14.2. Any question, guys, about this? So if you are to wire this system right now based on 2011, you have to wire it with 14.3 instead of 14.2. Any question? Did you guys see how what I brought the neutral? What do you do with the neutral when you bring it here? Cap it with a wire knot and push it inside. It's not. Where can you land the neutral on a switch? There's no spot for it to land. And the idea, everybody knows why we need a neutral there. Why the code came up with changing the neutral? Dimmers. You have dimmers. You have electronic equipments, motion detectors, anything that need a neutral to work on. Just as reference to work on. In the past, they used to allow you to tie it to the grounding conductor. Bad idea. Now you have to tie it directly into the neutral conductor. So if I have a dimmer or if I have a motion detector that needs a neutral, the neutral is sitting right in here. You just tie it to the neutral versus in the past, you have to tie it to the ground. Now to make the system completely right, now I want to remind you, this is my box. You still need to bring your grounding conductor with the system here, right? This is my ground. So how many conductors we have? 14.3. Well, we don't count the neutral. Always. I don't know why they don't. In cables, they always say 14.3 plus ground. Always. Ground is In 2000, was it in 2002 they started grounding the receptacles. Before that, you did not need to ground the receptacles. Any question, guys? So you are the lucky ones that's going to be graduating with the new change code where the neutral have to land on a switch. I can't emphasize on a switch, land in a box that has switch, the lucky ones. I can't emphasize, guys, one little thing. Only if you're wiring with cables, only if you're wiring with cables. If you wire with conduits, guess what I just said, goodbye. And some exceptions with open walls when you wire, you don't have to do it, or top or bottom. Open, you have an exception. And these switches have to control lights. If they're controlling a fan, bathroom fan, for example. No. It's good, but look at the bathroom fan, it's usually a combo. Most of them, well, some of them are a combo light fan. Now you have to put a neutral there. Any question, my friend? Did I drill this one little bit, this change in you? That's good. Induction heat. The second thing I want to mention is induction heat. Induction heat, guys, if you take this. Here's my phase A, my phase B and phase C. And I'm going to put phase A in one conduit here, and phase B in conduit here, and phase C in the other conduit. Now, if you do this one, each phase in each conduit, and these conduits are metallic, you guys know every time a current goes through a cable, create a magnetic field. So you are creating a magnetic field around the cable, and if you put anything metallic around the cable, that magnetic field will induce current into the enclosure around it. Long story short, you grab that conduit and it's hot. You have just created what we call induction heat. Induction heat. Cable 1 in conduit, cable 2 in another conduit, and phase 3 in the third conduit. Because of this, guys, the smarter than Chad decided if you have a circuit, all your conductors must be in one cable or one conduit. So if I'm to pull these, I have to pull them all in one cable or in one conduit, or if I'm burying them in the ground, I have to dig a trench and put them cable by cable right close in the close proximity with each other. Meaning, I can't put one here 5 feet, put the other one there. By doing it this way, by grouping them, guys, the three phases, the way they're designed, the magnetic field will cancel each other. The magnetic field from phase A, B, and C will cancel each other, so you will reduce tremendously the induction heat, number one. And one thing that you guys don't pay attention to is the impedance. The three-phase impedance will be reduced if you group them together versus you put them separately, which means your voltage drop will be less. So, question, you always group the three phases and the neutral and the ground in one cable or in one conduit or one trench or in one cable tray. If you have a cable tray and you're sitting in, you put them side by side. Any question, guys, about this? Why induction heat? There is stories, guys. The contractor will tell you stories about glowing connectors. You have a cable coming into the box right here and carrying 400 amps, and they landed them in one phase at a time into the conduit, and the connector that connects the cable in here, it's glowing at night because it's so hot from the induction heat. So you can research online if you don't believe Chad. The rule is always group all the conductors of the same circuit. So in the same cable or in the same conduit. Same cable or same conduit. Any question, guys, about that? Induction heat, magnetic field, induce a current and a voltage in the conduit, and circulate the current, and it start heating it up. That's why this one at the bottom is wrong. Everybody can see why this is wrong. What's wrong with this? You took the phase in one cable and the neutral in another. Can I do cable? I can't do it. The phase in one, all conductors have to be grouped together. All conductors of the same circuit have to be grouped together. There's some installation exception. When you have big conductors, guys, medium voltage and so forth, they pull one cable in a PVC conduit by themselves because the conductors are so big. But when they terminate them in a box, there's nothing metallic that hold them. But all the conductors have to be in the same, as far as you're concerned at this point, all conductors have to be in the same conduit or cable. conduit or cable. Okay, shall I give you guys 5 minutes break? Stretch a little bit. Okay, let me reconvene. Since let me go, where are we here, Chad? Okay. Since this is guys talk about branch circuits and so forth, we're going to talk about we talk about color identification. Now I am telling you, is this wiring okay? Is this wiring, everybody knows how to wire? Is this okay? This is 14 to 14 2. Is that okay? Based on the code 111. Why? Well, the neutral is right here. Let me just show the boxes. Here's the box. And here's the, is this okay? This is looking at the, is this okay based on code 111? Yeah. You're bringing the source, the circuit to the switch, and you're going to the light. Did you guys talk with Ryman about what's the best way is bringing the branch, the home run to the light or to the switch? A lot of discussion. I wired overseas, and well, at least what I was being told is always you bring the branch circuit to the switch, so you're guaranteed a neutral there, and then you go to the light. But here a lot of people like to bring the branch circuit to the attic, to the light, because from there you have the attic, you can steal it and go somewhere else. Both of them are good wiring methods. Okay, so any question about this? Everyone should be able to. Chris, I'm not going to test you on your wiring skills, but I tell you, as a good designer, guys, you should be able to wire simple circuits like this. Simple circuit. All right, so that's a couple of wiring. Three-way switches. Oh, by the way, if you look how many terminals, they ask about terminals. If you look at the switch, this is called terminal. If you haven't encountered, how many terminals a single pole, single throw switch has? 2 terminals, one hot, one switched hot. Now, Phil, this is always, the bottom one is always the hot, top is the switched hot, right? Everybody knows what a hot switched hot? You bring the power to the hot spot. This is the switched hot going to the light. Okay, now how many terminals in this? 3 terminals. 3 terminals. As you guys, if you haven't known that, if I want to wire a light between these 2 3-way switches, which I know some of you guys have thrown 3-way switches all over. So the first thing you know, the travelers always tie the travelers together. If you guys haven't wired that before, right? Always. Rule number 1: tie the travelers with the traveler. Okay, where do you guys want to put the light? Let's put our light right here. Okay, where do you want to bring the circuit? Okay, here's 2 switches and here's a light. Where do you guys want to bring the circuit? From which switch? Let's just bring the circuit. Let's say our circuit is coming from here, and I'm going to use my neutral right here. My neutral and my hot. My hot. Everybody should be able to see when you three-way switches. The first, when you land, I'm coming to this switch. First, you land the hot into this terminal, and the neutral. Oops, the neutral. Now my neutral comes to the switch. Have I met the code by bringing a neutral to the switch? Right, the switch, I've brought the neutral to it. Then what do I need to carry? So I brought the neutral to the switch, right? Then I need to bring the neutral back to the neutral from with them all the way up to the switch again here, right? Because these are 2 switches, you need to bring the neutral with them to every switch of them. Now, and then from the switch, from here we go to the light. Anybody has any issues with that? Anybody has any issues with that? Is that okay? Is that okay wiring? Is this an okay wiring? All right. So what's the missing? Where's the missing link? The hot. So where should I take the hot from? From right here all the way to the hot. Okay. Is this wired to the code 2011? Let's check. How many conductors do I need here? Most likely this will be 14.2, right? The reason why I'm showing this because you guys are going to be taking off this project that you're doing. You're going to be looking at it this way. Bringing the home run to the first 3-way switch is what? 14.2. Why do I need 14.3? Just bringing it. Remember, with the ground, always ground doesn't count. The ground is with the ground. All right, let's go over here. Right here, how many conductors do I have? This is 14, 3. 14, 3, right? 2 travelers and a neutral. In the past, the neutral was not used in the past. Okay, so come over here. Up to here, how many do I need? 14, 2. Have I met the code by having a neutral in every with every switch? Yep, does. Any question guys about this? You should be able to wire these, all of you guys, and because of estimation. When you take off, later on you're going to be taking off this stuff. You're going to ask me, Tom, my friend, how many conductors, how can they take this cable if you don't know if it's 14.3? Because when we show it on the plan, guys, you've seen how we showed it in the plan. On our plan, these will be shown as a switch, 3-way switch, and another 3-way switch here, and a lighting fixture, L. And what I asked you guys to do, the way we show it here, is you're bringing the power to here, and you're going to have your home run, ground, neutral, and hot, and this is my home run, right? That's how we wire it. And based on the way we're showing it right now, we came from switch to switch, and from third switch to the light. So this will be also a ground, a hot, and a hot, 2 hots, which is the travelers, and from here is going to be a ground and a hot and a neutral. That's how you show it on the plan, right? Isn't that what we wire it?
To the light bulb should be 2.
To the light bulb should be a hot and a neutral. The other one with that little dot is the ground. Yeah. I didn't show the ground here, guys, but if I have to show the ground, which color should we use the ground with? Red. Oh, we use red. I'm going to use the blue. Oh dear. Black. I'm going to use a black as a ground here. So here's your ground, just to make things. Here's my ground, and you grab the ground, you ground this switch, and you grab the ground, and you go here. I'm not showing the ground, right? Any question, guys, about these wiring? So, Chris, this is how we're going to show it on the plan. When I do take off, Rob, my friend, you're going to be taking off. Kind of, you're not going to show it, but you're going to be visualizing that between these 2 switches is actually it's a 14.3. You know what I mean? So this will be, I'm sorry, there will be neutral here. I forgot the neutral. So there should be 2 hots and a neutral, right? 14.3. So there'll be a 14.3, 14.2, 14.3, 14.2, right? Any question, guys, about this? Any question? So now, Nick, my friend, give you these, take you to our lab. You should be able to wire them if you haven't done that before. Okay, 4-way terminals. 4-way terminals, guys. Was it you, Phil, that you said you're going to use 4-way switches, I think? Or did you? Huh? Yeah, you're going to use 4-way switches. If you were to use 4-way switches, guys, 4-way switches always are used with 3-way switches. You can't use 4-way switch by themselves. So if you need, here's how it goes. I don't know if you guys ever were told this way. If you need to switch a light from 100 locations, 100 locations, how many of these 100 locations have to be a 4-way switch, and how many of them have to be a 3-way switch? 982, right? Everybody knows that. The 2 at the end, 2 of them must be 3-way switch. Everything else have to be 4-way switches, right? So that's, you got that one. So suppose that then just to simplify the issue, here's a switch here, a 4-way switch, a 3-way switch here, and I'm going to put a 3-way switch right next to it here. And your wiring method is going to come, it's going to come, you're going to come from here to here, from here to here, and from here, how I'm going to come up here. Let's go from here up to here, and from that one is going to go up to this side, right? That's really the thing that you do, is you tie the travelers to the travelers from both ends of the 4. Everybody knows that these are 4 terminals. They ask about 4 terminals. 4 terminals. 2 terminals go to this side, and 2 terminals go to the other side of the travelers. Any question about that? Then let's put our light. Can we put a light, guys, here just for, suppose that my light is right here. Ignore that. Suppose that my light is right here. Here's the terminal, and here's another terminal of the light. And I'm bringing my power from right in here. Take this. I'm bringing my power. Here's my neutral. I'm bringing my power from right in here, right? So what do you guys think where the neutral is going to go? The neutral has to go to here, terminate just right here, not on the terminal. And we have the three-way switch. Oops. There you go. And come over, oops, I want this color. Come over here, terminate right here, and come all the way to this neutral side. Okay? Any questions about that? This is, by the way, is not terminated anywhere else here. This is just coming in here, being spliced and going back. Right? Done. Let's wire the other side. What's the other side? We're going to wire to the switch. Then from here, you're going to go all the way up to this side. Are we done? Have we met the code and are we done? Have we met the code and are we done? Yeah. Do we have how many when you guys come over here? Let's use a black here. So this is 14.3, 14.2, right? Coming here, how many conductors do I have here, guys? 2 plus, this is 14.3 with a ground. How many conductors do I have here? Right? 14.3. How many conductors do I have here? 14.2. And how many conductors? That's it, going all the way. Any question, guys, about that? Very, very important to be able to, again, you're not electricians, but you should be able to wire a 3- and 4-way switches secondhand for you. Later on, we'll go commercial, guys. You might be able to use, they don't use a lot of 3-way and 4-way switches in a commercial because, you know, energy code and all this occupancy sensors and whatever. But it's really nice to be able to look at 4-way switch and 3-way switch and wire them. Any question, guys, about this? There's a few wiring problems at the back of the book. I strongly encourage you guys to take a few seconds and look at them. Okay, 2-pole. If I have, here's my load. Suppose this is a light. Suppose this is a light. And do I need a neutral here? Question, do I need a neutral? Here's hot 1, hot 2. If it's anything other than light, who cares? If it doesn't need a neutral, doesn't need a neutral. Do I need a neutral? If the equipment is more than 1 to ground, guys, if you don't need if equipment doesn't need a neutral, then you don't need a neutral here. So here you don't need to pull a neutral. You don't need to pull a neutral. Any question about that?
Well, if you use motion detectors or something, do they operate on the same voltage?
They will be operating at 240. The motion detector, if you're using a motion detector right here, most likely these are tied to 240. Combination devices, guys. How many of you guys have seen a device, a GFCI at the top and a switch at the bottom? That's what they call it, combination devices. So you can have different possibilities. You can have 2 switches. How many of you guys have seen 2 switches in one yoke? Switch at the top, switch at the bottom. These are really nice for retrofit and doing all this good stuff. Tab cost. The last thing I want to do before we do a couple of wiring here, guys, is timers. Timers, we have, I'll show you a couple of pictures of timers. Timers, here's where you're going to be doing timers in our project. Do you guys remember the light in the utility room? All the public lights in this building. Take this. Number 1, the stairway, common stairways between all the apartments. Swimming pool light, garage, driveway light, outside light for the building. All these are common lights. So you have 2 options. Either you have a switch available for all the tenants to turn it on and off. One option, put them all switches where the tenants, every tenant can walk into every switch, turn it on and off. That's a rule. Every tenant. So you can't put a switch in a tenant in another tenant's apartment, right? So put them in switches, no problem. The second one is if they're put them in motion detector, dusk to dawn. What do you call it? Motion detector and help me here with you, photocell. Thank you. You put them in a photocell, but these common lights, outside common lights on photocell, so they go on and off by themselves. Nobody have the outside ones on photocell. That's another option. A third option, most likely will be desirable to do, is in the utility room and in the in the utility room and in the stairway. If you don't want to put switches, you can put a timer. You turn the light switch. When you turn it on, it takes the timer to count for say 50 minutes. It will be set for 50 minutes, so the light will stay there for 50 minutes. If nobody again push the timer, it will go off until somebody else come and push the switch again. Push the switch or turn the switch. That's one. So that's probably where a good. This is commonly used. We did them in Jerusalem a lot of times. You push the button. Anybody have seen them in apartments here? I haven't seen them a lot. When you walk in, you push the button and you activate the timer for 15 minutes. So you go down the stairway, blah blah, and you can push the button on every landing. There's a button that you can push. Anybody have seen them here? Not commonly used. So in our application, in the stairway, you have two options. Either you turn them on and leave them on at all times, no problem, or you put them in a switches so people can have in the stairways handle to them. That's what we've done in the past. Or you can put them in a keyed switches but somebody has to go key them on and key them off. It might not be a good application for you. The most common for apartment like this, guys, is we'll put them in a 3 and 4 way switches basically. So you put them in 3 and 4 way switches, turn them on, they all go on until somebody else turns them off. The stairway and the utility room. Now the swimming pool and the outdoor, it's nice to put them on a motion detector and photocell motion detector. Any question, guys? Timer is another application where you could put them on a timer, as I said, where it times out, light will go off. The timer, we use them mostly in the commercial, like parking lots and all the stuff. You put them in a timer sometimes if you don't have an occupancy sensor. So you turn them on at certain time, off at another time. Here, then we use them. You can have occupancy sensor on them. Not occupancy sensor, motion, not motion detector, occupancy sensor. Help me here. The photocell. Photocell. You can put a photocell with turn on and off individually, or you can put them in a contactor or timer and turn them on and off. We'll talk more about the lighting contactors, guys, and timers later on. But you can put things on a timer. And what happens with the timer, guys, you can have 2-pole timer, single-pole timer. And you have to have a neutral, and you wire them, and basically you set your timer electronically or mechanical timers. When it times out, it disengages the hot and the neutral, or the two hots. So anybody ever wired a timer? You guys wire timers? So that's what. But where would you be a good application for a timer here? Probably outdoor. Other than outdoor, might not be a good application for a timer. Fountains. We got that one. Got that one. Got that one. Got that one. Wiring. Yeah, a couple of things I didn't mention, guys, is NEMA configuration. NEMA configuration has all the receptacles that we use in the US. Has a NEMA configuration. If you look at the top one, the most common, it's called this baby here. It's called 5-15R, R for receptacle. 5-15P, that will be, if you see a 5-15P. Anybody knows what a P is? Plug. What an R is? Receptacle. This becomes very handy, my friend, when you go into a commercial project that need plugs. And I can have 50 amp plug that goes with 50 amp receptacle. So these are, you don't have to memorize this one. Look at this, 5-20R receptacle, that's up to 15 amps. Look at that baby, This is 6-15R. That's rated for 250 15 amps. This is 6-20R. This is 20 amp, 250. The idea, guys, like us and the British, this is a common practice. Here's this is equivalent to our 15 amp. This is 13 amp receptacle. This is a 13 amp receptacle, and this is a 15 amp receptacle. The voltages are different, and the amps are different. Look at the configuration different. You cannot plug a plug that rated for this one into that one. And everybody knows why, right? Two things. The worst thing that could happen to you is you plug an equipment in a plug that's higher voltage or higher amps than what the equipment is rated for. Higher amps or higher, because higher voltage will burn you, higher amps will give you more amps, and lower amps will actually kill the receptacles too. Lower amps, if this receptacle rated for 15, imagine what happens if I plug a 20 amp load in it. It's going to burn that baby. So mainly higher voltage or lower amps. You don't want to put higher voltage, plug in a higher voltage here, or lower amps than what the receptacle is rated for. All these configuration, guys, in the DeWalt book that I gave you, also they're all listed. Configuration, electronic equipment, loads. Okay, is it under receptacles, switches, and so forth. There you go. If you guys go to chapter 4, if I ask you, here's the question would be on the test. Now for the test chat. If I ask you, if the question, tell my friend, would be, what would be a 5-15R? NEMA 5-15R. What is it? The last thing I want you is to memorize it. You can memorize it. Or, oh, by the way, this is open. My tests are open DeWalt Professional. If you guys go to page 4-5, it will tell you, oh yeah, it's a 2-pole. It's a 15R, and it will give you all the configuration, all the connection for all the NEMAs. All the connection for the 120, 250, and if you guys look at the 10-20R, 10-30R, and so forth, 1-15R, NEMA 5-15R.
What's the significance of the first digit?
Here it says 1 instead of 15, 1-15R. This one is saying, now it's confusing me. One says 10, 1-15R. I think the first digit is sequential. There's a table nicer than that, guys. I'll give you. The first digit is sequential. We'll talk about the identification of that one. Where's that NEMA? I have a book, guys. There's a copy of all these NEMAs. But for the time being, how to hook up, how are they hooked up, what voltage, what amps right into 4-5. And if you go there and find L in front of it, guys. Okay, here's 2-pole 3-wire grounding. Yep, yeah, 5-15. No, I was looking at the wrong one. It's 5-15. Yeah, I think the 5, 1, 2, 3, 5, guys, is the sequential number in the NEMA. So 5-15R and 5-15P as the plug R. If you see, and I don't want to make any NEMA stuff here, if I put here, right here, L, do you see that, Phil? If I put L in the front of it, it becomes locking receptacle. You guys know that 15 amp locking receptacle? The one that it's round and you lock it, right? So L, if you see an L in the front of it, this is for locking receptacle. L515R is a 15 amp 120 receptacle that you can lock it. Any question, guys, about these configuration? 99% of the time when you're doing residential, guys, this is your choice number 1. This is your choice number 2. Very few is number 3 if you're going to get into number 3 like this. 15 or number 4. So that's basically what you're going to be doing. Receptacle, different configuration. A couple of things that you can see, guys. I think this is a pilot receptacle. This one here, you guys have this picture. It's a switch receptacle. Have anybody seen a switched receptacle where you have to stick the switch in it, turn it on, and turn it off with a switch. When would you use something like this? If in a hallways in a school, you don't want the kids to be playing with the light on and off. You put them in a switch receptacle. Pilot light, I think this represents the pilot light. You guys have seen that little receptacle light that when you turn it on, what is it? When you turn it off, some of them when you turn it off, an indicating light, a pilot light will go on to tell you where the location of the switch is. A few applications. So that's give you a few applications where lights are with covers. We talked about this one. If you're digging a trench, remember how we said you're going to group them even in a trench? Because of what? Induction heat and reducing the impedance. So that's where basically going to be grouping them, close proximity. This will be basically a disaster. What's wrong with that one? Look at this here. You're not grouping all the conductors with the same circuit. You're not grouping them all the conductors with the same circuit. So you have to when you do the wiring, guys, you have to pay attention that all your conductors have to be grouped together. All conductors grouped together. So you have white not used. You have to group all your conductors in one circuit. So we have to rewire this system. There's a couple of rewiring that we can do on that one. So you have to rewire. We talked about this one. Talked about this one. Three-way switches and the light. Light. Yep. Is this valid anymore? Is this wiring valid anymore? And what do I need to make it valid? Neutral. But remember, the neutral is coming right here. Look at this. Look at it this way. Is this valid wiring anymore? These are boxes. Do I have a neutral to the switch? Yep. So that's okay. Valid. No problem. Because the circuit is coming at the switch. Talked about this. Pilot light. Three-way switches. Is this valid based on 2011 anymore? Is it valid? Valid wiring. Do I have a neutral at every switch? And neutral at every switch? And neutral at every switch? Right? And neutral at every switch? Neutral at every switch? The travelers, and the hot. This is my hot. These are my travelers. This is my neutral. Travelers again. This is switched hot, right? That's my switched hot all the way. And this one will be switched hot. This will be my neutral. So perfect wiring, no? Okay. Let's look at this one and tell me if this is valid wiring. Is this a valid wiring, and how many wires do you need? The first thing you see, do we have a neutral at every switch? Yep. How many conductors are here to make this system work? Look at that. This is interesting. How many? Okay, 14. This is a 4-wire conductor, a 3-wire conductor. And how about this? 2-wire, right? You guys see that little one that I don't know how many of you have seen before? Where did it go? This is the 4-wire conductor now that you're going to be using right in here. Before that, we could have gotten away without the white and use a 3-way conductor. So can you guys see what we do with the switch right here? We're at right of the switch. We just terminate right. It's not tied to anything else. Just wire knot, and you wire knot it and leave it inside the box. Any question guys about these wiring? That's the only change from when you guys did the wiring, is bringing a neutral to the switch if you're wiring with cables. All right, is this valid wiring? And I know you guys probably have done that, but remember how you can bring the circuit to the light or to any one of these switches, right? So look at the source of the power is coming from right here. This is my source of power. My source of power. Do I have travelers? Did I identify the right travelers? Yep, I did not use white for traveler. Here's my white coming. Here's my white coming, sitting there for future use, right? My lighting fixture is tied to the white, and my switch, my travelers are right here. Can you guys see the travelers right here? And to make the system work, what conductor cable do I need? How many conductors in this cable you need? How many conductors you need? This is a 4, 14, 4 to make the system work. How about here? 14, 4. How about here? 14, 2. This is where your 14, 4 is becoming a big deal. 14, 4 conductors becoming a big deal. Any question, guys, about a 14, 4 that's going to be commonly used? Here's my question for you. If I have a 14, 4, can I use the white conductor as a traveler and re-identify it? No. You can't use the white conductor as a traveler and the blue as a neutral. No. So for the most part, that's why I said kiss your re-identification goodbye, right? Any question? This is one of the most important things where 14.4 will become very handy. Yes, sir.
Now, what's the role of the neutral, the switches? What work do they do there?
What's that?
The neutrals, you know, you terminate the neutrals and the switches.
Why?
What are they doing there?
In case you have to in case you install a dimmer or something.
Or motion detector.
Why are they bringing the neutral? Well, the idea came again. If you're using motion detector, suppose that this switch is a motion detector and you need neutral. So there would be a terminal here, and you bring it and you tie it to the neutral. Suppose that after it was installed, I decided to have a three-way switch with a motion detector. I don't know if they make them. A three-way switch with motion detector. The motion detector needs a neutral. The neutral, why does it need a neutral? It needs a neutral for the electronics to work. Because motion detector, it's sending a signal, comes back, it interrupted, and it turns a switch on or off. So to do this function, it needs some little current. That current is going to come from the hot, but it needs a reference. Where is it going to go? You need a reference. A reference in the past, they used to use the grounding conductor as a reference. Tie it to the grounding conductor. Ooh, you don't want to do that. Now you can tie it directly to the neutral. Does that make sense, guys? When you wire it, if it's only three-way switch, so what do? You're going to cap it with a wire knot, push it in, and leave it for future use. The second thing I guess, the second advantage could be an advantage. Really, here it's not an advantage. If I have a receptacle here, and this is where you guys are going to be completely out of whack in a few. If I have a receptacle here, no problem, Chad. I can steal the neutral from here. The ground is already there. Where am I going to get the hot? Look at the hot. I have a switch on this side, and I wired the neutral. The neutral is there. Where am I going to steal the hot?
No hot input on S3.
Okay. Which one of them is the hot?
The common. You want the common.
These are travelers. Is this the hot?
Yes.
Yeah, that's it. So that's my hot. You're going to come from over here and steal. So that's an advantage, right? Now directly from a three switch, I got hot and neutral. Let's go do the same thing right in here. Here's my switch. My neutral is here. I'm going to steal my neutral. My neutral is, did I do it to the right direction? The neutral is going to be right here, right on the left. My hot. How about my hot here? Do I have a hot?
No, switch.
It's a switched hot. So what are you going to do? It's a switched hot. So you need to grab another wire. Where's the hot? The hot is right here. You're going to grab another wire from here, bring it all the way to here and tie it. And that will make it 14.5. I'm not aware if they're making it. Why am I saying this? I haven't seen it. 14.5. I haven't seen it. 14.3 here. 14.4 here. So why you need to be aware of this, guys, now, if you have, especially Phil, because you're wiring with a lot of three-way switches and four-way switches. If you're to sneak and feed a receptacle from it, be aware that you might not have a conductor that can do this work. So if you're in this situation, what would you do? Suppose I'm in this situation. What am I supposed to do, Chad? Okay. We can have a 14.2 and a 14.3. Yep. You can solve one neutral with this, another neutral tied. Or, how about if I use a flex? We've used it, guys, in bathrooms. A fan need more wires in a fan. Flex. How about if I use a flex and I fill that flex, right? Now I can fill conductors, not long. I can use a flex and I pull 5 conductors, number 14, and a ground node. So it's going to be on a ground. Can I do a 5 conductors and a ground and flex? And then you land it in a metallic box. No problem. You can put metallic box for here because it's flex. You need a metallic box for both sides. Can I do that? Yeah. That would be a good solution if you are in this situation to use a flex. Or, like you said, 14.2 and 14.3 get you there. Cheaper. Yeah, 14.2 and 14.3. So you can solve this one as we said, 14.2 and 14.3. The problem is, you might have to go 14.4 here. Why?
You gotta keep your own.
Because you have to keep your own neutral with the same circuit. So you really have to basically pull 14.4 to pull the neutral with the same circuit. Because yeah, this one has its own neutral with it. How about these? These are 3 wires with no neutral with them. Their neutral is sitting in another cable. So you have to use 14.4 and 14.2 to make it work. Or a flex with less wires. Any question guys about this? This should be second nature to you when we do the takeoff. The reason why I spend some time on them, because when we do takeoff, you guys are going to identify which one is 14.4. Luckily, Phil, we're not tying the receptacles to the lights. I'm asking you to separate them. And that's a good advantage now, especially now, by separating receptacles from the lights. Our requirement, not code. So if you're separating the lighting circuit from receptacle circuit, you would never be in this situation because you can't mix them up. Only our requirement, not code. Any question, guys? Any question? So I'd like to spend some time, as I said, on that one because we talked about 4-way switches. Here's a 4-way switch. What's nice about this picture is you guys have the same picture that I do. If you forgot how, and sometimes we do, how to wire a 4-way switch, great. You have the 4 terminals, as you can see. Always remember, what I always remember, the 2 terminals here go with the 2 terminals on both ends. Now, here's my question for you, Nick. Does it matter if I grab these 2 from the bottom to the top and the top to the bottom? Does it make a difference? Does it make a difference in a 4-way switch? Have I met the code by bringing a neutral to every switch? Yep, neutral to every switch. Re-identified, make them the travelers the same color. Red, 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 all the way through. And the cables that we're using, because of this, I have to use a 3 cable and a 3, and right here would be what? A 2. So depending where you bring the circuit, you can either, the worst scenario is the one just with, if you bring the circuit to the light, you have to use a few 14.3, 14.4. Any question guys about wiring these? Any question? You do take off tau, my friend, you're going to get, you know, between these receptacles, you have to have 14.3. Last, so when you guys do this one for me, here's my lighting fixture, here's my, this is my 3-way, this is my 4-way, this is my 3-way, and here's how you're going to be wiring it. Grab this one, you have your ground, your neutral, your hot. Grab the other one. I want you to identify this one, the 3 conductors. So hot, hot, neutral, and a ground. I want you guys to put this one because it's different than the home run. And right here, grab this. The same thing is going to be a ground, a hot, a neutral, hot, and a hot. And all the way here, then to the lighting fixture. The lighting fixture, I don't want you to identify this branch because it's what? If it's not identified, it's identical to the home run. If it's different than the home run, please identify it when you do lights. Did you guys hear me? when you do lights, if the home run is, this is home run is 14, 14, 2. If anytime you diverge from 14, 2, I want you to show the slices, the slashes. For what reason? We really don't do them in design, because when you do take off later on at the end of week 8, it will be very easy for you to look at them and say, yeah, that's 14. In this case, this will be a 14-3 cable. This is 14-3 cable, and I know that this is a 14-2. Because if it's not 14-3, the default is always 14-2. Any question, guys? So that's how we're going to show them in design, and that's how we're going to be wiring them in practical. The one thing I don't like when I hear one of the designers say, I don't know how to wire. You know what I mean? My father-in-law is electronic technician. He wires better than a lot of people, guys. Wiring for dummies from Home Depot. You can buy a book and you can wire at least a house. You should be able to wire. It's not hard. I'm not saying you're journeymen, but with the code, the amount of code that we give you, you actually know a journeyman work. The code. And then the hands-on skills, you know, how to terminate it and where to terminate it and all this good stuff, that's not a big of a deal. I hope you terminated the fuel. Sorry, Chris?
Oh, I rewired my house, this is 20-some years ago, I bought the wrong book, I bought commercial, so I wired it to commercial standard. You know.
So it's number 12 and...
Yeah, the inspector came in and said, you run a business here? And I said, no, why? And she said, well, you wired it for commercial purpose, so I spent 2 times more than paid.
Well...
Save some money on the labor.
Yeah, so you spend the money that you saved on labor. Look at this, guys. This is if you bring this is where it becomes an interesting situation, where you're bringing your light, the source to the light. So you agree with me, this is 14.2, right? Going from here up to here, this is also 14.3. So here's my neutral. Yep. Do I have a neutral? Yep. Do I have a neutral here? Do I have a neutral here? Yep. So I have my neutral. To make the system 4, this is 14.4. And this right here is 14. Yep. This will be a 14.4. So looking at it from schematic, when you guys design it with Chad, this is 3. This is 4. This is 3. And this is my L. You're going to do, let's use a blue here. You're going to go with a hot, neutral, and ground like this. You're going to come from here to here. This is from here to here. We need a hot, a ground, a neutral, and how many hots? 1, 2, right? This is 14, 14, 3. Can you guys see that? Coming over here, this is going to be 1, 2, 3, 4, and a ground. Then make it. So when you guys design it, you're going to come up with a hot, and a hot, and a hot, and a neutral, and a ground. Is that 14? 1, 2, 3, 4. 4 conductors with a ground. And this one also over here, 1, 2, 3, 4, 5. So that's what I want you guys to show. Why? Because when we design it, we know what type of cable are we using. Any question, guys? I will bring to your attention now how the neutral went all the way, and I brought the red and the red, black, and blue, red, black, blue, to do the travelers. So I used the red and the black as a travelers, and the blue as a returned, as a hot, actually, as my hot. Any question? Any question, guys? Does that help you guys with the new identification, especially? Okay. Now, if you have a multi-wire branch circuit like this, this is a multi-wire branch circuit. If you have a multi-wire branch circuit, this conductor will be 14.3, right? And this circuit will be, if you are using this, guys, this will be circuit hot 1, hot 2. If you are to do this in a schematic, this will be L, and this is the another L. And the way you're going to do it, you're going to bring the home run right here, hot, neutral, and neutral and ground. And then from here, you're going to come to here. And we all know that between, you're going to have a hot, let's say the ground, and a neutral, and a hot right here. So by showing it, this will be circuit 1, 3, apartment panel -1. That's how we're going to show this one in yours. By looking at it 1, 3, guys, and showing this will be a 14 3 cable. This will be a 14 2 cable. By showing it this way, I can tell that these are 2 circuits. Most likely this will be in circuit 1 and the other one will be in circuit 2. Any question, guys? How do we wire them? You're looking at it. Where's this? I didn't have a switch. The switch, I didn't show the switches. The switch would be, in this case, my switch would be right in here. This is just a 2-pole switch. 2-pole switch. We have a symbol for it. So you're going to grab here, coming to this, and going out of the 2-pole switch with the same configuration. 1, 2, 3, 4.
For marking the cable gauge and conductors, why do all the hashing?
You only do the hash if the hash is different than well, in this case, because it's highly unlikely, if it's different than 14.2. When you do lights, if it's different than the home run, you hash it. Why do you hash?
You've got the cable gauge and conductor size. It's like very redundant information.
Oh yeah, you're not going to write the 14.2 and 14.3. Yeah, no, on your plans, you're not, this is just FYI. Everything that I'm circling here is FYI.
Yeah.
Yeah.
You're not doing that.
Yeah, you're not doing both. No. You just put the hashes to give you the idea. But what I circled is just FYI. You don't put them on the plans. Any question, guys? This is a multi-wire branch circuit, as you can see, sharing a neutral. 2 circuits sharing a neutral. 2-pole. We talked, guys, about this light off. This is a lamp or pilot lamp. Anybody knows how this system works? Anybody knows how this works? Now, when the light is off, if this is R, this will be close to, let me say, 50 times R. What happens, guys, is when the light is off, the voltage, you have 120 volt here. The 120 volt, 100 and let's just say 10 volt go across this, and 10 volt go across this. Look what happened. This is really interesting. They put a pilot light in parallel with the switch. So when the switch is off, you have close to 50, well, around that 150 times that load resistor, huge resistor, compared to the load right across the switch. So guess what? If you put, you guys remember the days of Ryman? When you put 2 resistors in series, the fattest, fluffiest one will take the highest amount of voltage, right? The fattest, fluffiest one will take the highest amount of voltage. So what does that mean? If this is a huge, then it will take 110 volt, close to 110 volt across it. So this light will go on, indicating that the circuit is off. And this load will have only close to 10 volt across it. And what happened for a light? If you put a 10 volt across a light, they need 120. You get a big nothing, no light. And that's how it works. Now, look at this here. When you shunt it, now the voltage across this one went to 0. Everything here, all the voltage went across the light goes on. Any question, guys, about pilot light? Or indicating light? Indicating light. Okay. I believe we have them here. Yep. Okay, so that's, everybody knows how this works, right? It's a huge resistor in series with another one. When the voltage, it hugs a huge amount of voltage, it leaves the leftover for the load. The load need this amount of voltage, and you're giving him this amount of voltage. So it just goes off. Indicating light to indicate that the light is the location of the light. Pilot light. So the one that you guys saw across is a pilot light. Just to tell you, where would you use a pilot light? In the attic?
The other switch.
Yeah, the light itself has the switch toggle has a little light in it. So if you're coming in the dark and you're looking for where the switch is, the switch will be lit. The switch handle will be lit. That's what indicating light is, the one that we just, so it leads you toward the switch. So when you turn the switch on, or when the switch is off, you turn it on, the light comes on, and obviously when you turn it off, the indicating light will go off. Pilot light. Pilot light, I used it a lot in the old days for boilers. You have a boiler, electric boilers, not gas boilers, and you would turn the boiler on or off. There's an indicating light that will tell you that the boiler is on or off. So this is really straightforward, guys. This will be part of the switch right here. So when the switch is on, a tiny little light will go on, indicating that this is on, this is on. When this is off, this load is off. So if this light is above the ceiling, right, and the switch for it is there, I don't have to look at the switch immediately. And I look towards the switch, I can see if the light is on from a mile away. Well, the mile is too big. From 100 feet away, I can look and can tell you that the light in the attic is on because that indicating pilot light is on. Everybody see where this could be a good advantage for it? Is this code? Do you have to do it? No. Is it a good idea? Certain application, attic light? Absolutely. I don't know how many of you guys have, this is multiple devices in the same yoke, or different devices in the same yoke. It comes really handy under certain applications. I don't know how many of you guys have used this. There's a different system where you can build them. There's so many ways of having your yokes. This is coming. Anybody install these? Did you? Here? There's a lot of, they're coming overseas, guys, where you can actually build your devices. You can grab this and dump it right in here, and then one will be like a little switch here. This part, you dump it here, and it will be a low voltage, a TV, and you dump it in here with a separation, though. There's separation between them. So you build your own devices. Not commonly, where did you use them? Not at home? Oh. Anybody ever wired with them? You build your own devices. Most of the stuff that we use in the US, they're 1 or 2 or 3 in one yoke. This is common, at least in other places. Okay, is this wiring okay, guys? Is this wiring okay between the three-way switches and the light? Ask yourself, do I have a neutral at the switch? Yup. Do I have a neutral at the other switch? Yup. Does my receptacle has a neutral and a hot? Yup. My light has a neutral and a hot? Yup. Did I keep the neutral and the hot in the same conduit? The neutral and the hot in the same conduit? Yup. I'm good. But then how many conductors you need here? 1, 2, 3, 4. There will be 4, number 14 inside the conduit. If this is PVC, what do you need also? 1 conductor number 14 for what? Ground. If it's a conduit PVC. If it's EMT, you can use the EMT as your grounding equivalent conductor. I hope, guys, I'm spending some good time because that's kind of a quick review. When I do the takeoff at 8 and you come to you guys and you're circling all your numbers, you're going to justify what conductor are you using between these devices. Okay, this could be a good example of a dimmer, guys. A good example of a dimmer. Here's my neutral. You ask about directly connected to the device. This is just to reference you, give you a voltage so it can cook the electronic equipment, meaning the electronic equipment will work. And here's my hot coming in, and my neutral, my switch hot going off. Hope this is not a gray though. Looks like a gray. Other than a gray, so it just say not gray because we don't want it to be a gray. Looks like a gray. Switches. Everybody knows how to wire. If you haven't seen where wiring is, my friends, for receptacles. Receptacles by code, you land the ground here, the neutral. This is your neutral. This is your ground, and this is your hot. If you haven't known that, we're in trouble now by now. All right, pigtailing is a very good idea. You guys know how to pigtail a circuit? Bring that little device up here, right? You tab and pigtail all these and push them in and bring it. It's a few wiring method techniques. Different ways of pigtailing, different ways of getting the ground. Okay, what's wrong with this one? Number 14. Okay, what's wrong with this? I got nailed by the inspector with that one. I want to bring to your attention, guys, a 20 amp circuit here, number 12 here, and then I went down with number 14. Can I do that? No. If you start with number 12, continue number 12. Actually, there was a situation where an inspector, if you use number, here's my question for you. Can I use a 15 amp and will solve the problem? Can I use a 15? If you put a 15 amp right now, would it solve the problem? Yeah. Except some inspector will look at it here and they say, Chad, you're telling me that you're bringing number 12 to the panel, right? Right. What happened when the owner looks at number 12 and say, well, I can get more juice out of this, right? And go take your number 15 and stick another number 20 here. Is there a possibility of overloading that number 14? Yes.
Same instead of putting in a 30 amp, the 20 amp now.
Yeah. You can, you're right, you have.
You can't go through
Yeah.
things with schools that don't see.
Absolutely. Another mistake here, guys, is what's wrong with this? If it's a conduit, do I need a neutral here? This is a conduit. Do I need a neutral to the switch? No. Why? Because in the future, if I'm to change this one to a motion detector, I can come over here and grab a conductor, pull it right in here, and tie it to the equipment. If it's a cable only, you need a neutral. Did you guys say that? Only cables, you need a neutral. MC cable, AC cable, NM cable, no problem. As long as you're in the cable, you need neutral. Okay, and we talked about the timers, guys, a couple of timers where you can load, line load, on, off. Here's a typical neutral. Here's a typical timer if you have not wired it. Here's coming out of here to the line. This is my hot one. Coming out of here to the neutral. Here's my neutral. So I brought the circuit to the timer. Out of the timer, I have a lighting fixture that will turn on and off. So out of the timer, I need to bring the neutral. Look at that neutral terminal come all the way tied to the neutral. And where's the load? From here, you come and you tie to the fixture. So can you guys see how we wired this timer? I brought a hot and neutral to the timer. Now by bringing a hot and neutral to the timer, you have energized the timer. Energize the timer. Because the timer doesn't work on hot only. You have to have a neutral, so if it's electronic or mechanical, or if it's electronic, you need to cook the electronic to get you the results. And then what happened is there's a tiny little switch right here, guys. When this times out and switch you into, and there's an on-off try, you can bypass it with an on-off. What happened with this with times off or on, times put you on, this will close, the light will go on, keeps going until it times off, it will open and the light will go off. This is the most basic timer that you can buy. The most basic timer that you can buy. Now take this. Now there's timers that you can add another one. Here's hot one. I can grab another hot here, hot 2, and I can grab multiple loads from here. So I can bring 2 hots to the timer, so I can switch 2 hots. And I can bring multiple loads to switch multiple loads from them. But this is basically the most basic timer. Any question is, set them up to turn on at certain time and off at certain time, right? If it's a mechanical timer like this. Here's an electronic timer, as you guys can see. The same concept, except the mechanical is electronic here. We talked about grounding, 15. Okay. The rest of them, guys, I want to do this one, and the rest are wiring methods. So I want to do that particular one, wire this one, and then you guys will do the rest of them, right? Wire the rest of them. There's a lot of wiring methods, wiring scenarios here. So I have a switch, and I have 2 lights, and I need, let's say I have, let's see, which color? Black and red. Let's say blue. I want to say here. Let's wire this. Oh, come on. Did you do something to my, okay, there you go. This is, let's say this is white. This color is white, just because I don't have a color. Okay, let's go wire this. Do you guys agree with me that I can come from here to the lighting fixture, tap it, go in. This is straightforward, right? And I have to bring this one all the way and land it right next to the switch, right? I brought the neutral to every light and to the switch. Anybody has any issue with that? I brought the neutral. The light need a neutral and the switch need a neutral. So you have no options. Do I have any other options, guys? Other than that? Okay, so the second one that I'm going to use the black as my hot. Here's my black. I brought the black up to here. I didn't tie it to anything. See what I just tied it? I didn't tie it to anything. I brought the black right here. Nothing. It's not tied to anything. It just spliced right in here and all the way. So what I did, I energized the switch. I need to energize the switch. So I brought my hot to the switch, right? Any question, any problem with that? Bringing the hot to the switch. If I bring the hot to the light will go on all the time. You can't turn it on and off. It works, but you can't control it. The last thing, my friend, since now each one of them has a neutral. The hot is next to every light, but it's not tied to the light yet. I switch the hot. Can you guys see I switch the hot? And I grab the hot right in here. Now this hot came land on this side, came here, and came land on this side. Can you guys see that? Now, having done so, this could 14.2. This cable is 14.3. This cable is 14.3. Any question, guys? Now each one of you guys should be able to draw what I did here with the right cables. Would it be wrong if I use the red as a black and the... No, wrong. You just put a black tape around it. But since you have a black, might as well continue with the black. Any question, guys? Any question about that? Any question? Having said that, so these are all coming from the back of your book, guys, as an exercise they're going to be wiring. So I want to let you do the rest of them, and then we can check them. There you go. There's another one. Here's a switch and a light. And here's a third one, a bunch of them. So do me a favor. Okay. Let's go back here, back here, back here. So can you guys do all these wiring? I'm not going to do them for you. We've done a few of them. Do them. And you should be able to wire with 3- and 4-way switches based on the NEC code 2011. I wanna indicate that these are all cables, so you need to bring the neutral to the switches. Any question? I'm not gonna do them. I want you guys to do them. It's not hard to do them really. Any question? You guys want me to do that?
Can we take a break? That's a question.
Yeah, I'm almost done. That's what I thought. Otherwise, I can do it. Shall we do it before we take a quick break, or are you gonna do it? Can you do it? Okay. I can check it for you. Okay, thank you. That's all I have for you. Go eat.